Hi, you might have learned that to find the sum and the product of the roots of a quadratic equation of the form ax squared plus bx plus c is equal to 0, all we have to do is to use the following formulas. That is, for the sum, we just need to compute for the value of negative b over a, and for the product, it is simply c over a. But how were these formulas derived? So in this video, I'm going to show you so that you could appreciate the derivation of formulas in mathematics. And in this case, I'll show that through the formulas in finding the sum and the product of the roots of a quadratic equation. So let's start with the quadratic equation itself. So ax squared plus bx plus c is equal to 0. Now note that this equation can be transformed into x squared plus b over ax plus c over a is equal to 0 if we multiply the equation by 1 over a on both sides. Now as we solve for the value of x, we could expect that this equation will be transformed into its factored form that will help us determine the values of the roots. Now let's say, for example, that if we continue to solve for those roots and ended up with the following roots, namely r1 and r2. So the factored form of x squared plus b over ax plus c over a equal to 0 should take the form of x minus r1 and x minus r2. Now, this is very critical in understanding how the rules were derived, because we have to take note that x minus r1 times x minus r2 is just the factored form of x squared plus b over ax plus c over a is equal to 0. Since it is the factored form, they must be equivalent. Okay, so take note, they are equivalent. And that if I simplify x minus r1 times x minus r2 is equal to 0, it should have the form x squared plus b over ax plus c over a is equal to 0. Okay, that's very important. So as we continue, now let us expand x minus r1 times x minus r2. So if I will expand this will become x squared minus r2x minus r1x plus r1 times r2 equal to 0. Now we could have many different ways of expanding it, and we will still be having the same expanded form. Okay, so this expanded form can be transformed into x squared minus r2 plus r1 times x plus r1 times r2 equal to 0. Also, we can still arrange r1 and r2 in such a way that we write r1 first before the r2. So we have r1 and r2 as the product equal to 0. Okay? Now, remember what I told you about the two equations being equivalent. So if I will have now the other equations be written just under the expanded form of x minus r1 and x minus r2, you will clearly see the relationships of the roots to that of the coefficients a, b, and c. Okay, so let's bring this down here. So we have x squared plus b over ax plus c over a is equal to 0. Since they are equivalent, then we could correspond the terms of the expanded form of x minus r1 times x minus r2 equal to 0 to that of x squared plus b over ax plus c over a is equal to 0. In short, b over a should be equal, so this is the b over a, should be equal to negative R1 plus R2, and that C over A must be equal to R1 times R2. And if you see it now, this is taking us to the two formulas that help us to find the sum and the product of the roots of the quadratic equation. Now the first one can still be simplified. If we multiply it by negative 1 on both sides, then negative b over a is now equal to r1 plus r2, which is simply the sum of the roots r1 and r2. And c over a is equal to r1 times r2 as the product of the roots. So see, these are the two formulas that we use to find the sum and the product of the roots of the quadratic equation. And that's how they were derived. Okay, so they basically came from the quadratic equation ax squared plus bx plus c is equal to 0. Okay, so the most critical part in understanding this proof or explanation on why the formulas work is that the roots of the equation gave us this factored form of x squared plus b over ax plus c over a is equal to 0. Knowing that it is equivalent to x squared plus b over ax plus c over a is equal to 0, we were able to make proper correspondence of the coefficients of the two equations. Hence, b over a is equal to negative r1 plus r2, and c over a is equal to r1 times r2. Okay, so I hope you understand now how these formulas were derived. So there is no magic behind it. These formulas came from or were derived from the quadratic equation ax squared plus bx plus c is equal to 0. Okay, so that's it.